Hey y'all, so in this video what we're going to be looking at is Unit 2 Part A, where we did a lot with our proportional reasoning. And in this video I'm just going to review how to identify whether or not certain ratios are proportional. We're going to review how to solve a proportion, and then I'm going to review the main difference between the types of problems where x might go on top versus when x might go on bottom for a word problem. Okay? So let's just kick it off here. Friendly reminder that proportional just means equal. So if it gives you a series of ratios set equal to another ratio and asks which ones are proportional and which ones are not, you've got a couple of options here. Some of you are just really good with your mental math, and you can see that right here, if we did 9 divided by 3, we'd get 3. But 27 divided by 3 is not 8. So this one is not equal. This is not proportional, okay? Now, another way to prove that in the calculator is to convert them both to decimals. So like if I did 9 out of 27, that's a 0.3 repeating. But a 3/8, you guys know, is a 0.375. So again, converting them to decimals proves that they're not equal. And last but not least, this kind of the safer method is to just cross multiply. You could do 9 times 8 and get a 72. And then when we do 27 times 3, we get an 81. So since these are not the same, these are not proportional, okay? Now for the next one, if we see that we've got 3 times 5 is 15 and 2 times 5 is 10, then yes, this is going to be proportional. Another way to prove it, again, to cross multiply, 3 times 10 is 30 and 15 times 2 is 30, so we don't even need a calculator. So yes, these are proportional. All right, now for the next one, if we did 6 divided by 3, we'd get 2. And 27 divided by 3 is a 9, so yes, this would be proportional. And we could also prove it by cross multiplying. 6 times 9 here is 54. And 27 times 2 is also going to be a 54. Now for this one, I don't expect many of you to be good enough with your times tables to see that 12 times 5 is in fact a 60, but 12 times 5 is 60. And now let's see what happens if we do 13 times 5. We get 65. So it looks like using a scale factor, yep, these are proportional. And just in case I don't imagine many of you catching the scale factor of 5, let's do 12 times 65. So that's a 780. So let's check to see if now 13 times 60 is also 780. It is. So we have a third proportional set of ratios. And now for the last one here, let's just check to see if we cross multiply. Let's do a 12 times 6. So 12 times 6 is 72. And then 13 times 5, we already did that one earlier, that's 65. So since these aren't the same, no, this is not proportional. Okay? So these three right here were proportional ratios. Now when we're trying to solve for an unknown, if the unknown is up here, again, you could identify a scale factor. Like some of y'all are really good and can catch that 9 times 5 is 45. So you could just do 2 times 5 to get a 10. But let's say you're not good at that and you don't want to worry about identifying a scale factor. You could simply cross multiply, then divide. So you can multiply the 2 and the 45 and then divide by the 9. So we've got 2 times 45. When we divide that by 9, we get 10. And that's the same thing that the scale factor people would have gotten for x. X here equals 10. All right, now it doesn't matter if the unknown is in the numerator or the denominator. Scale factor method still applies. A couple of you would catch that 5 times 2 is 10. So we're just going to do times 2. So 2.5 times 2 would be a 5. I've got another way with a scale factor. Some of you see that this 2.5 doubles to be a 5 here. So what would double to become a 10? And that's another way of proving that this is a 5. And again, if we want to cross multiply, we're going to do a 2.5 times 10 in the calculator. And then we'll divide that by the 5. So same answer, y is 5. So you've got a couple of options. You could either identify the scale factor and be good with your mental math, or just cross multiply, then divide, and you can solve a proportion. Now, the last part of this video, I just wanted to walk you guys through two different scenarios because I wanted to point out that we don't always put X up top and we don't always put X in the bottom. We have to kind of decide. It just depends on the problem. So for the first one, it says if it takes you 5 minutes to read 3 pages of Wonder, that's the 5 and the 3. I've got 5 minutes and 3 pages, so that's the first ratio that was given. How long will it take you to read a chapter that's 18 pages? Well, I'll highlight here that we put the pages down here in the denominator. So 18 pages is down here in the denominator. We had 5 minutes up top in the numerator, and the unknown is also minutes, so that's up here. And now we can simply cross multiply and divide. Some of you might catch that 3 times 6 is 18. So if it's 6 times as many pages, it should take 6 times as long, which would be 30 minutes. All right. Now for another question we have here, if a 5K race is 3.1 miles, so we've got the kilometers up here and then miles down here. If a 5K race is 3.1 miles, how long is a 10K race? Well, 10 kilometers is now up here and our unknown is miles, which is now down here in the denominator. So you just got to be careful. It depends on what the question is asking and how it's set up. But sometimes X will go up top and sometimes it'll go down below. But we already reviewed how to solve this. So here we could either just catch the scale factor. So 5 times 2 is 10. Therefore, 3.1 times 2 would be 6.2 miles. But again, cross multiplying and dividing will work. We've got 10 times the 3.1. And now we'll divide that by the 5 and we get 6.2 miles. All right, that concludes this video on reviewing how the proportions work. Thank you for watching.